Next is the geometric tolerance system. Geometric dimensioning and tolerance system, that is in short GD&T, is the method of defining parts based on how they function using the standard symbols. In the last two or three tolerance system, in unilateral, bilateral and the third one method compound tolerance system, there are some errors or some disadvantages are there, that if you are going to have a functionality of any hole or shaft which are meeting with each other and as well as rotating or transferring any power, in that case if you are only looking at the unilateral or bilateral rotation system, then they should not function properly. So in order to have the proper functionality of the product, we are utilizing now GD&T symbols. This is the standard method in which standard symbols are utilized to have a specific characteristics. So this frame indicates the feature control frame. Okay, there are several features which are to be controlled while producing any product. This symbol represents the roundness or concentricity of these two shafts. First shaft is this one with a smaller size and second shaft is this one with the bigger size. So we have to maintain the concentricity of this shaft particular with this rotating frame. Okay, if these two parts are to be mated with the another part and these are to be rotated, then it should have a concentricity in order to have a power transmission effectively or without any losses. So how to control that feature is using the GD&T symbols. This symbol or frame has three boxes. First box will indicate the feature that to be controlled using manufacturing process. Second frame will indicate, or second box will indicate the tolerance limit up to which we are going to control that feature, and third will indicate the reference plane or any surface or any feature with respect to that one we are going to control the feature. So by this symbol or by this diagram we can have a conclusion that this surface is to be maintained concentricity of 0.01 mm, cylindric or radial tolerance is there. This symbol indicates the radial tolerance. We have to maintain the concentricity of this particular shaft within a radial tolerance limit of 0.01 mm with respect to surface X or this surface X. Okay, if that frame is readed by any worker, then it will produce this shaft dimension within a size of 0.01 with maintaining a concentricity. So they should be functional properly with each other. Diameters of the cylinders need to be concentric with each other for proper fit between the two cylinders. Both the centers to be in a line. This information is represented in a feature control frame. The feature control frame comprises of the three boxes. First box on left indicates the feature to be controlled, represents symbolically. Example, center box indicates the distance between the two cylinders. Centers cannot be apart by more than 0.01 mm, and third box will indicates the datum is with X. Okay. Then we will see now about the maximum and minimum metal conditions. We are dealing with the tolerance system in which we are thinking about the minimum limit and maximum limit. In order to production, we are going to have two different definitions of maximum metal condition and minimum metal condition. So consider a shaft having dimension of 40 plus minus 0.05 mm and a hole having a dimension of 45 plus minus 0.05 mm. So for shaft maximum metal limit, okay, by this only you are knowing that the shaft side should be such that it will have a maximum metal on it, while least metal condition or minimum metal condition will indicate that the shaft side should have a minimum metal on that shaft. So you can see that if the maximum limit is will indicate the maximum metal condition, as the shaft has a 40.05 mm size, it will have a maximum material on it itself, while for minimum size, the shaft will have the minimum metal on it. So by these figures, you can clearly have the idea of minimum material condition and maximum material limit. So for the shaft, maximum limit or upper limit will, or maximum size will indicate the maximum material condition, while lower material condition will indicate by the lower limit or minimum size. For hole, that conditions are opposite in manner that of shaft. So for hole, maximum material will be on hole if it has the minimum size, and it will have a minimum material on the hole if it has a maximum size. You can see by these two lines, if the hole has a maximum, that is maximum material condition, it should have a minimum limit or size, so that this metal or this portion of metal it will cover. So you can see that it has a maximum material on it if it has a minimum size. Then we will move towards the fits. It has 3 fits: transition fit and interference fit. The slide fit have by class of fit H7, H6. It can be utilized in sealing rings, bearing covers, movable gears, in change gear trains and clutches, etc. Easy slide fit can be utilized by class of fit H7, G7, red spindle, spigots, piston and slide valves. Running fit will be utilized by H8, F8, size limits of the hole and shaft. This clearance fit is utilized in lubricated bearings with oil or grease, pumps and smaller motors, gearboxes, shaft, pulleys, etc. Slack running can be utilized by using H8, C11 symbol, oil seals with the metal housing, multi-spline shaft, etc. Loose running fit can be utilized using H8, D9 fit with loose pulleys, loose bearings with a low revolution. Then interference fit, force or press fit can be utilized by symbol of H8, R6. This fit, force fit or press fit, is utilized in crank pins, car wheel axles, bearing bushes, in casting, etc. Driving H7, S6, plug shaft slightly larger than the hole. Tight fit by the symbol of H7, P6, step the pulleys on driver shaft of the conveyor. Shrink fit H7, U6, H8, U7, bronze crowns on worm wheel hub, couplings, gear wheels and assembly of the piston in isolation. Freeze H7, U6, H8, U7, insertion of the exhaust valve seat inserts in the engine cylinder blocks and insertion of the brass bushes in the various assemblies. Transition fit, it has 2 types. Push or slung fit can be utilized by the pair of H7, K6. This utilized in pulleys and inner rings of ball bearings on a shaft. Wringing fit can be have by mating H7 and N6 shaft. Gears of machine tool application is there. Then general terminology of fits. Okay. Then by this figure, you are knowing that H or the capital letters are utilized for the hole. H size will indicate the basic hole, which has the lower limit equals to the zero line or basic size. Fundamental deviation is the minimum deviation or closer deviation towards the zero line. Okay, and zero line will indicate the basic size. Clearance fit. Okay, so what is meant by clearance fit? In clearance fit, the hole size is higher than that of shaft. The shaft can be easily fitted inside the hole. Okay, so you can see by these 2 figures that the hole with the minimum size is also has a size more than the maximum size or maximum limit of the shaft. So we can have a definition of clearance fit as the type of fit in which the maximum size of shaft is always or smaller than that of the minimum limit of the hole. Okay, always we are know that there should be clearance. Clearance means the gap. If you are going to maintain a gap in a hole and shaft assembly, in that case, always there should be a shaft size that should be smaller than that of the hole size. Okay, so maximum size of the shaft should be always smaller than that of the minimum limit of the hole. Okay, so H7 and F6 will have the clearance fit. Also H7, F6, okay, clearance is there. Okay, so you can see in this figure that this is the maximum clearance or minimum clearance or fundamental clearance that can be achieved by using this clearance fit. Next one is the hole basis and shaft basis system. To obtain a desired class of fit, either the size of the hole or the size of the shaft must be varied. We cannot vary both the sizes, that is hole size and shaft size. We have to maintain a constant of any one of the hole or shaft to have the desired class of fit. There are two types of systems used to represent the three basic types of fits: clearances, interferences, and transition fits. These are the hole basis system and shaft basis system. First, we will see about the hole basis system. The size of hole is kept constant and the shaft size is varied to give the various types of fit. We can have a clearance, transition, and interference type of fit by keeping the hole size constant and by varying the shaft size. That system is known as hole basis system. Okay. Of the hole is always 0. That is, lower limit of hole is same as the basic size. The two limits of shaft and the higher dimension of the hole are varied to obtain the desired type of fit. Okay, you can see by this figure hole basis system. The first figure indicates the clearance fit, second one is the transition fit, and third one is the interference fit. We are knowing about the clearance fit, in which always the shaft size is lower or smaller in size than that of the minimum limit of the minimum size of the hole. In transition fit, the shaft can be smaller or higher than that of the hole size. The shaft is always greater than that of the maximum limit of the hole. Always we have to press fitted this shaft into the hole. That fit system is known as interference fit. Interference means overlapping. So we have to overlap the shaft dimensions on that of the hole dimension. Okay, so in hole basis system we are keeping the hole size constant. You can see that here the hole size is same. Okay, and we are varying the size of the shaft to have a desired type of fit. By keeping the dimension of the shaft lower than the minimum size, we have a transition clearance fit, and by keeping the hole size smaller than that the shaft size, we are having an interference fit. Transition fit is in between the two lines. Okay, so in industry of India, we are utilizing hole basis system, and that in order to have a hole size, we are having a manufacturing processes like drilling, rimming, etc. In industry or in market, we are knowing that the drill size is fixed. We are having diameter 5/16, 5/18, etc. Drill bits are available in the market or in industry. So drill bits are having a higher price than that of single point cutting tool. We are manufacturing the hole by using drills or reamers, etc. Okay, or boring, etc. So this costing is more than that of the cutting tool. We can vary the shaft size by using a simple single point cutting tool on any lathe machine. So in order to vary the shaft size is more convenient than by varying the size of the hole. So we are keeping hole size same by using one type of drill, and we are varying the shaft sizes by utilizing or manufacturing it on a lathe machine by a single point cutting tool. We can have a types of fits. This system is widely adopted in industries, easier to manufacture shaft of the varying size to the required tolerances. Standard size plug gauges are used to check the hole size accurately. Also, the checking of the hole is more convenient in case of hole basis system. So we are utilizing hole basis system in our industries. Then what is meant by shaft basis system? The size of shaft is kept constant and the hole size is varied to obtain the various types of fit. That system is known as shaft basis system. Fundamental deviation or upper deviation of the shaft is zero. System is not preferred in the industries and is required more number of standard sizes tools like reamers, broaches and gauges, increases manufacturing the inspection cost. Okay, we can see from this figure that the shaft size is kept constant and we are varying the size of hole. Imagine that we are producing a shaft on a lathe and that size is kept constant. And in order to have a different types of fits, clearance fit, transition fit and interference fit, we are varying the size of the hole. Okay, this hole, if it has a high size of 518, that should be produced by a reamer or drill bit of 518, while if the size of hole is 516, then we have to again go to market and buy the 516 drill bit or reamer in order to have a transition fit. And if you are utilizing interference fit, then the size, if it has a size of 514, then you have to buy that another third tool to have an interference fit. Okay, so this system will have a number of tools increasing, or our inventory is increasing on the tools. Okay, and checking of this hole should be done by using plug gauge. Though again we have to buy another set of plug gauges to check these types of holes. Okay, so it bit investing in our drilling as well as inspection tools if you are preferring the shaft basis system. So this system is not preferred in the industries. Okay, you are getting what I am trying to say. Hole basis system, the hole size is kept constant. In shaft basis system, we are keeping the shaft size constant. But hole basis system is most preferred in industries because the production of the shaft as well as checking of the shaft by utilizing simple investment is done. So we are preferring that one in industries. Okay. Next we will see about the tolerance symbols used to specify the tolerance and fit for the mating components. For example, consider the designation 40H7D6. You are always seeing this symbol on your drawing, engineering drawing, as well as the plug gauges, ring gauges, etc. So what it means, the 40 will indicate the basic size of the shaft and hole. The shaft and hole that are to be mated with each other, it has a basic size of 40 mm, while these two letters will indicate the shaft size and the hole size. Okay, so and type of fit. Okay, the nature of fit for the hole basis system is represented by H. If you are utilizing H, capital H, then it means that it indicates the hole basis system. The fundamental deviation of the hole is 0. 7 will indicate that it has a hole, it has a tolerance grade of IT7. This hole with H fundamental deviation and IT grade 7 is mating with the shaft of D type fit and fundamental deviation of negative value with the IT grade of 9 tolerance grade. The first 8 dimensions from A to H for holes are used for the clearance fit. Designations J to ZC for the holes are used for interference or transition fit. If you are having here H, A to H, then it will indicate the clearance fit, and from J to CZ it will indicate the interference fit. The fundamental deviation, the deviation either the upper or lower deviation nearest to the zero line is called as fundamental deviation. It provides the position of the tolerance zone near to the zero line or in positive side or in negative side. Upper deviation designated by ES for a hole and ES for the shaft. So what is my upper deviation? Which is the maximum allowable size or difference between the zero line and maximum size of hole or shaft is known as upper deviation, while lower deviation is known as the difference between algebraic difference between the zero line and the lower limit of hole or shaft. Okay. This symbol or diagram indicates the typical representation of different types of fundamental deviations. Capital letters for hole and small letters for the shaft. So if you are meeting H with the H, it will have a basic deviation as a 0 fundamental deviation. Okay, from A to ZC, there are several types of tolerance are indicated on this diagram. Similarly, for the shaft, if you are meeting this A with the A, you can see that this A fundamental deviation is above the zero line and this A tolerance zone is below the zero line. So with the shaft and hole having the same basic size, clearance fit. If you are moving from A to H, it will have a clearance fit, and if you are moving from H to ZC, you can see that shaft size is above the zero line while the hole size is below the zero line. So it is interferencing with each other or transition with each other. So these fundamental deviations will help us to choose the right combination of the hole and shaft size in order to have a required type of fit. Okay. There are some formulas to calculate the fundamental deviations by the IT grades. Total 18 grades of fundamental tolerances are available in designation of the tolerances. Designation by the letters IT followed by the number. As per the BIS or ISO, it has 18 grades: IT01, IT0, IT1 to IT16. Tolerance values corresponding to the grades IT5 and IT16 are written by using the tolerance unit I in micron meter. In order to calculate this I, we are having a formula of I is equal to 0.453 cube root of D plus 0.001 D, where D is the diameter of the part in mm, 0.01 D is the linear factor contracts the effect of measuring inaccuracies. Value of tolerance unit I is obtained for the sizes up to 500 mm. D is the geometric mean of the lower and upper diameters. You can calculate D is equal to square root of D max into D min. By using this symbol I, we can calculate the tolerance zones. Tolerance grades D is equal to various specified defined as follows. Then these are the standard tolerance limits for this I value is indicated here.